Welcome back, guys. This is Teddy Talks, and I'm Expedit as usual. We're still under stoichiometry, and now this time we're going to see how do we calculate the percentage composition of the mixture. And of course, this we are doing them with live examples. We have an example here which says calculate. The example says that question 1, 2.1 grams of a mixture of potassium chlorate and potassium chloride were heated until evolution of oxygen was complete. Question: calculate the percentage of potassium chloride the percentage of potassium chloride in the mixture. So that is our question. They are asking us to calculate the percentage of potassium chloride in the mixture. Now, this question you have to be careful and analytical. One, they have said the mixture has potassium chloride and potassium chloride. The two were heated until evolution of oxygen was complete. Now, one, you should be careful. Where does the oxygen come from? Potassium chlorate decomposes to give us potassium chloride plus oxygen gas. Now you realize that we have oxygen is 3 here and is 2 the other side. So what do? We balance it by putting in a 3 here. When we put a 3 here, oxygen becomes 6, but here it is 2. So if we put a 2 here, this oxygen also becomes 6, and consequently, this term also has become a 2. So this is the equation for the reaction. Now, the question is, how much potassium chloride is in this mixture? The reason we are not having potassium chloride on the reactant side is simple, that the chlorides of group 1 hardly decompose on heating. So when you heat potassium chloride, it is not going to decompose, it will remain there. It is only the chlorate that decomposes to again give more potassium chloride and the oxygen. So let's try to answer this question. Now, question number 1. What is the mass of oxygen in the mixture? This question has some missing information. Let me read it. The residue weight, they are saying that the residue weighed 1.62 grams. Then comma, calculate the percentage of potassium chloride. Calculator. Now, when we go to our calculator, how do we get the mass of oxygen? The mass of oxygen is going to be got from 2.1 minus 1.62. This minus this, I think it gives me 0.48 grams of oxygen. Now we have known the amount of oxygen that was developed by this mixture. Now, the next question is, how much potassium chlorate in the mixture decomposed to give this oxygen? Because it is this chlorate that has decomposed to give oxygen. And when they say there is complete evolution of oxygen, it means that there is also complete decomposition of potassium chlorate. Now, here, let's begin by again calculating the molar mass of potassium chlorate. We know that potassium is 19, chlorine is 35.5 plus oxygen, which is 16, so times 3. So this becomes 39 plus 35.5 plus 16 times 3, then our answer times 2. So the molar mass here is 245 grams of potassium chlorate. Now, when we look at our equation of reaction again, when we interpret it, we realize that this molar mass produces this amount of oxygen. Now, how much oxygen is here if we are to interpret this equation in terms of mass? Now, when we interpret this equation in terms of mass, we realize that this is 3 times 16 times 2. So that is that 3 times 16 times 2 gives me 96. Therefore, 96 grams of oxygen are produced from the decomposition of 245 grams of potassium chlorate. But for us in our question, we had 0.48 grams of oxygen, therefore 0.48 grams of oxygen is produced by 0.48 times 245 out of 96. So 0.48 times 245 is equal to that value divided by 96. So here we realize that this is 1.225 grams of potassium chlorate. Now that is the mass of the potassium chlorate that was in this mixture. Now, having known the mass of potassium chlorate in the mixture, and our question said we should find the percentage of potassium chloride in the mixture, it means the next step we will move to is finding the mass of potassium chloride. Of course, the mass of the potassium chloride is going to be equal to mass of mixture minus mass of potassium chloride. So this is 9 Now, what was the mass of this mixture? This mixture, remember, had it had oxygen. This mixture had potassium. It had potassium chlorate. It also had potassium chloride. But we realized that this of it was given out as oxygen. So, what mass are we left with in that scenario? Now, this is going to be 2.1 minus 1.225 grams. So 2.1, sorry, 2.1. So our mass here of potassium chloride is 0.875 grams of potassium chloride. But the question was asking for the percentage of potassium chloride. The percentage of potassium chloride is the mass of potassium chloride over mass of the mixture times 100. So this gives me 0.875 divided by 2.1 times 100. So answer divided by 2.1 times 100. And therefore, the percentage of potassium chlorate is 41.67%. So that is the way we would carry out that. Maybe to recap it one more time, we have said that when you have a mixture of potassium chlorate and potassium chloride, potassium chloride does not decompose when heated. It is only the chlorate that is going to decompose to give out the oxygen. Now, the oxygen that is given out will help us to determine the amount of chlorate that is in that mixture. Now, if we know the amount of chlorate in the mixture, we subtract it from the mass of the mixture, and therefore we get the mass of the chloride. And since they were interested in the percentage of the chloride, then it is mass of the chloride over mass of the mixture expressed as a percentage. And that's why we are having it like that. And from our calculation, we find out that there's 41.6% in the mixture that was potassium chloride. We meet in the next session. Thank you.